Welcome to the Occupational Safety Leadership Podcast. This is episode 167 with Ken Barat. And today we're going to sit down and talk about lasers. Lasers are one of those things that you hear about, and of course they're all over the movies. They destroy planets. They do all kinds of neat things out there. They can cut steel. They can etch. They can. But let's kind of come back to the real world and talk about how we use lasers out there in the everyday world. And before that we get started, Ken, could you do a little bit of background and tell the audience about yourself, please?
Well, sure, David. My pleasure. Uh, so I was the laser safety officer for Lawrence Berkeley National Lab, the oldest of Department of Energy's basic R&D labs. I was the laser safety officer for National Ignition Facility, the people that are doing laser diffusion research that about 2 years ago announced that they had a shot that actually created more energy, out than they put in.
Wow.
And I've been doing laser safety for, as you can, those would can see with the white beard for 30 years. And I do laser safety advising for all sorts of places. I was the laser safety advisor for the LIGO folks, gravity waves things. I've just recently come back from Hawaii to the Keck Observatory, helping them out with some laser issues. And I have a quarterly column on laser safety and photonic spectra. I have a number of textbooks written, just a lot of experience with lasers. And at one time, the state of Arizona had an independent agency on radiation, and I was the laser group leader for that. So ran the regulatory program for the state of Arizona. So do a lot of experience with all different type of laser applications. So that's kind
Awesome.
of me.
Awesome, Ken. Awesome. I guess before we really get into looking at different like particulars and scenarios and all that kind of stuff, could you do just a little background on all the different laser classes out there, please?
Sure. So the laser classes, when people say, "What class laser do you have?" This is basically a hazard communication device, and the idea is if you may not know much of anything about the laser, as far as wavelength or other things, but if you know what class it is, you sort of get an immediate feedback on how, either how what type of risk it presents to you. So we have the starting on the low end, we have the class one laser that by definition doesn't put out enough power to cause eye or skin injury. And it gets confused all the time with a class one laser product. So that's like if you have a laser printer on your desk, the laser that's inside that does the actual work is a higher class. Actually, it could cause eye injury. But the fact is, during normal operation, and the key is normal operation, it's all contained. There's no hazard, there's no risk. That's why they're not required to have a laser warning label on the outside of units like that. And if you now have bought a laser cutting device for work or home craft type of things, cutting uh, leather, metal. I actually found someone that was cutting chocolate with their with
Oh
their
wow.
unit. You know, just have to have the imagination. Uh, those are class one products, even though the laser inside is considerably higher. So then we have class 1M, which is an invisible laser, but it's a large diameter beam. So the beam is so large that the power per square centimeter is below eye hazard. So unless you look at it with some type of collecting optics,
Hmm.
it's not a hazard. So you see this in free space communications where they're sending a laser beam from one building to the other, kind of like line of sight microwave tower. Then you have class uh, 2M, which is the visible version of class 1M. Then you've got class 2, which low power laser, less than a milliwatt. What it counts on is your eye doesn't like bright light. So if someone shined that at you. The feeling is your aversion response, your body's natural response to bright light. You would turn away in less than a quarter of a second, and you would not have enough energy in your eye to cause permanent damage. So the early laser pointers, particularly when they were all red, were class 2 devices. Then we have a 3R, which is 1 to 5 milliwatts, which is what all the laser pointers are labeled at. If you have a advancer for your PowerPoint and it's got a laser in it, a 3R. Once again, you're safe for momentary viewing, but you wouldn't want to look at the beam through a pair of binoculars because it would focus a smaller spot. Then once you get past, all right, so before we get to 3B, where laser safety gets to be important, in Europe, there is something called Class 1C, and the C stands for contact. So there are a lot of home devices you can buy to remove hair, remove wrinkles. That's what they're
Mm,
sold at. And but their class, really the power is like class 4. It's a higher power. So we don't want people holding a handpiece and waving around, this class 4 laser. So it's engineered so that the handpiece must be in contact with your skin. If it's not in contact with something, it will not fire. So the beam is actually contained. Uh, so you have a lot of, those are, like I said, it's not a recognized classification here in the States. Maybe, 10 years it will be. But it is, what you can find that in Europe on some medical devices there. Uh, so once you cross the threshold above 3R, now you're above 5 milliwatts, you're class 3B, which can be visible or invisible. And 3B's got a pretty wide range. It's from 5 milliwatts to 500 milliwatts, to half a watt. And those lasers potentially could cause eye injury. And they're generally not strong enough to do a skin burn, but they definitely can damage your eyes. Once you're past half a watt, you fall into class 4, which today has no upper limit. So it can be visible or invisible. So whether it's 1 watt or 500 watts or 100,000 watts, they're all class 4 lasers. And those are the ones that, since there's no upper limit, they have potential for eye injury, skin burn, can ignite things. They can really be very hazardous. But once again, if I've got a you know, 550 nanometer, 550 milliwatt laser. Yes, it's class 4, but it's not the same, risk as 1,000 watt, laser. So in that way, there's been a lot of interest in having a higher class, like a class 5. Uh, and this has been pushed by the folks doing laser weapons development, because they've got megawatt power or 60, 100, 500 kilowatts of output. And they would like to have a higher classification to designate that type of power. I actually like 4L, L being lethal. But
mm,
so far, the ANSI committee uh, has rejected that because committee's feeling has been that there's not a unique control measure. You still want to keep people out of the beam. You want to give training. They don't feel there's something unique. While the people that work on these systems feel, oh, there are definitely unique things about this type of power output. But once again, this is something that will bounce around. And since the ANSI standard only gets renewed every 7 to 10 years, uh, down the road, maybe, but how soon, I don't think anybody really knows. So those are the classifications of lasers. Uh, I can say, laser technology has made a quantum leap. I mean, it dates back to the 60s, but there was a time if you had a laser, you needed a team of grad students to keep it up and running. You know, it's like owning certain type of sports cars. It's in the shop more than it's out on the road. You know, uh, but the now it's solid state lasers and laser diodes. Uh, you know, lasers are being used everywhere. I early on, I was knew some people that were doing laser dental development. And at first, even though they had systems that would, remove soft tissue gums and do cavity work, the fact was that no dentist wanted to buy it because the support was so intensive. Now that you have a solid state system that you plug and play, you turn it on and beam comes out. They don't need anything else. And it's like the old days with phones. If your phone was broken, you didn't fix it, you got a new one. I mean, the price range has dropped to that point. So now you're seeing, lasers in dental offices and all sorts of devices that lasers are being used at. I've recently been dealing with some people that are doing laser welding, and which has many advantages over traditional uh, welding techniques. And same thing goes with using lasers to clean graffiti off cement and clean statues and stuff like that. You don't have hazardous chemicals, you don't have hazardous waste to deal with, but it's a class 4 laser, and you're holding it in your hand and the beam is coming out. And all sorts of, what type of safety do I have to provide to the user and those around them? But lasers are everywhere, and I'm not aware of any area in modern society that doesn't have some laser situation. You know, uh, if if you have a problem with pigeons on your roof, there's a laser system that will scare them away. You know, and not only is it your roof, but there are laser scarecrows where you can buy in a cornfield that will periodically send out usually it's a green beam to scare birds away. I mean, it's like everywhere. One of the interesting one, which uh, I know has been developed, but I haven't seen a lot of use, is lasers to deflect lightning. You know, basically, it's a system that sets up so if the weather indicates, the weather issue, or like thunderstorms are coming, it sets out a false like plasma ring or plasma beam. So the lightning goes down that rather than hitting your power line.
Wow,
Is
that is
something that,
neat.
yeah, I mean, there's some really fantastic. Now, not all these things have been adopted or I think fine tuned enough, but a lot of work's been done on that. And actually, I just think it'd be if you're a good salesman, you sell one on the block, deflecting your lightning to the neighbor's house, and then they want to get one deflected down the road. So I just think you know, it's going to be there. But lasers are just showing up everywhere today, and the issue for laser safety is while we're excited to see laser technology spreading, a lot of times people don't appreciate the hazards because it's become so commercial. One last example I'll give you is the mom and pop trophy shop where you
Oh
go
yeah,
in and they engrave the plate. Well, it may not be much of a laser hazard because it's usually a fixed setup, but what about the fumes that are giving off? Most of those are carcinogenic. So how do they ventilate it? Do they ventilate it? you know so they're commercial products, they're out there for the public, but is safety being addressed? And the thing that I find is people say, well, if it's an improved product, if it's got all the bells and whistles on the as a product, well, that means it's safe. Well, a label doesn't keep you safe.
right,
It's
exactly.
so like I said, lasers are everywhere, and there's that. So on the thing about like enclosures, as you'd mentioned, so
Mhm.
you can buy these units that will cut out pieces of plastic and like leather and all sorts of things, and they're generally totally enclosed. You put the lid down, you do it. You want to do some marking something, the part comes in, the door's closed, laser fires. But all those systems are pretty much made with a interlock that can be bypassed. Why? Because you may have a workpiece that's bigger than the enclosure, or something that doesn't fit. So now you bypass the interlocks, and that probably means you have the enclosure open. Well, do I have to worry about reflections coming out, or what issues with that? So even though you may have a class one product, do you appreciate these off normal, I would say, applications and uses? I've certainly been to places where once the device is interlocked, it's never removed. The interlock stays there forever. And all the safety devices are now useless because they've been defeated. So
Hmm.
there's sort of
Hmm.
the story with all of that. But you know, like I said, if you've got some type of cabinet system where the machine's not supposed to fire unless the doors are closed, I mean that's great. But there's certainly been cases where people have bypassed it or uh, didn't realize that the beam was still on and reach in. And I mean, there are issues with that. So there are incidents that are happening. Not luckily, not a large number of laser accidents, but potential is always there.
Hmm. Hmm. I think that that you can also pick up things that have a long-term effect, but you don't really know it. When you kind of think about you talked about all the fumes and the exhaust from it. Then I know that the ones that I tackle, we exhaust the whole inside. It goes through a whole series of filters. We shoot it outside afterwards, and all that stuff. Then those are a little bit intensive to really go back and make sure, the filters are good, they're changed on a regular basis and all that good stuff. And we have it because we take it serious. But I have talked to a couple of safety folks who, because it counts as a extra, and the person who buys it doesn't really understand that it just counts as extra. So I'm not going to pay for extra, of course. I'm gonna get that laser in. They get it in, fire it a couple times, and then they figure out like, uh-oh, it's got some fumes to it. It's got some things happening to it.
Yeah, well, I mean, without a doubt, and even people that have filters, many times I find, they oh, the manufacturer says this filter is good for 3 months. They don't think about the duty cycle of how much you're really using it and how much it may get clogged up. Uh, yeah, I mean, it's anytime you talk about an expendable or some extra thing that doesn't get presented as part of the sale. I mean, I at a research lab, I once recommended to a user that they get an interlock for their door, and I'd said, "Hey, there are a couple ones out there. This one costs you $1,500." And the guy said, 1,500. Okay, I'll get it. I got like a month later, I get this irate phone call, and he says, "Well, uh, you didn't tell me that not only is there $1,500 to for the hardware, it cost me $3,000 to have facilities electricians come and install it on in my,
Yeah.
in my room." And I said, I have two electricians come in, they're charging me, full time for each one, and next thing I know, I've got this huge bill. And I said, well, surprises me too, but that there you got to look at the big picture all the time.
Right, right, right. And that's why that I really stress to folks to understand the entire concept first and then really present that package. So like you said, there's a lot of people that they'll buy it because they want to buy it, but they don't think about all the other cost, and then that'll just snowball into, well, now it's not a real project anymore because but if people know the real cost up front, they seem to be a whole lot easier about things too. And the vendors do a pretty good job of giving you a total package as long as you buy a total package, of course, and not I can buy some cheaper filters here. I can run my own ductwork in another way and all that stuff.
Without a doubt. And you really have to really work with the salesperson. You have to feel they're being straightforward and honest with you on what your needs are and all of that, which is why the typically the smart buyer, if you have a choice between a class 4 device and a class 1 product, you're going to go because the other thing, the once you get to 3B and 4 from the standards perspective, you have to have someone responsible for laser safety. Operators have to be trained. There's signage, there's administrative things you need to do. And that becomes something that's another effort involved, training of people and how you're going to go about doing that. So like I said, once you get to 3B and 4 look class lasers, the standards say there are things you need to do to have an effective safety program. So right now here in the States, uh, we have federal and state OSHA programs. And while they're responsible for worker safety, they really don't have any regulations on lasers specifically. There are a couple on construction lasers, but they generally consider those to be de minimis, below any real concern. So, but what OSHA says is that if you want to demonstrate you have a good laser safety program, then you should be following the ANSI standard. So you, we have a number of ANSI standards for laser use, and that's how you're supposed to base your program on. And so if you get an OSHA inspection and they cite you under their general duty clause as, is their authorization to say you're not providing a safe work environment because you don't have an LSO, you haven't have an enclosure and things of that nature. And yes, but I will say sometimes I think that the ANSI committee forgets, they like to say that we're just providing guidance, and they sometimes don't want to acknowledge the fact that their guidance is almost regulatory
Yep.
from the government's perspective. And sometimes things get put in that sound really nice, but they don't think about the burden to the user
Hmm.
on what it means to actually, do that and how practical it might be. So, uh, uh, having a long background in research labs, uh, one of the best mottos I found for a safety department once was safety through cooperation. You got to
Oh.
have
Mhm.
buy-in. You have to have buy-in from your users. I mean, I personally can design a laser safety system for someone that I can guarantee no one will ever be hurt, but I can also guarantee probably no work can be done. So you need to find that balance between the two,
Mhm.
and so it's a partnership. Laser safety, I think, is much different than number of other safety disciplines. If I'm a ventilation specialist, I come in, I measure the flow rate, and I tell you to put the sash this high or increase the blower, and you may not see me for another year. Laser safety officer, they're supposed to do periodic visits, help you see your controls or help you develop the controls, make sure the controls are being used. They're around more often. I think, and it's more intensive, at least to me. Once again, another underpaid occupation is
Mhm.
all I have to say.
Mhm. 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 Yeah. Yeah. So when it comes to lasers, for me, I've only used those cabinet ones. I've been really super lucky every place I work that I've been able to. Well, I hate to say force, but I've been able to convince folks that we need to have it as a class one product for the operator, and all that kind of stuff. Then, um, can you think of any benefits to having a open beam as opposed to a cabinet system?
Well, it's the real thing to me is we say open beams. I have open beam path. Well, how long is that open beam path? There are you know, robots on the assembly line that the beam path coming out of the robot arm is, 1 or 2 centimeters. So therefore you've got an open beam, but the likelihood of anyone, getting close enough to get in the beam or get a reflection is so low, it's almost like an enclosure because they
Right.
can't get close. And you've got other systems where the open beam is, uh, you know, greater distance. And like I mentioned, if I'm doing cleaning with a laser wand of metal parts, uh, I may be 3, 4 feet away from the metal part, and I have an open beam all that distance. Well, there are a lot more issues involved with that, and so it varies on what you're doing. The very interesting thing, the regulatory agent in the UK is now pushing the concept that if you need to wear laser eyewear, that tells us or tells them that your laser safety program has failed, that you cannot
Interesting.
enclose things enough. If you have to wear eyewear, it means that program's not, your system's not protected enough. So a little dramatic. I have, it'll be a long time before the U.S. is ready to go that way, but it is definitely a different approach. But like I said, open beams depends what you're doing and like I said, the operation that you are. But the other thing mentioned, there are a lot of laser systems that when they hit a target, they actually generate ionizing radiation. So that gets to be another thing, that people may have to be concerned with. But there are usually people that are doing systems like that pretty much already well understand that that's what they're doing and
Hmm.
uh,
Hmm.
have other controls uh, for that. But uh, yeah, so there's those things. And as technology keeps advancing, uh, it's a real challenge for regulatory people and for the standards because the laser welder, even though generally the beam path is pretty short and the laser cleaning device, those really are outside the general uh, description of lasers in the standards because
Hmm.
they're thinking more of the traditional type of laser.
Hmm.
So as new technologies come along, and when the standard only gets done every 7 to 10 years, it's very easy for them to be behind. Uh, you know, I have a column showing up. I think it's in the November issue of Photonic Spectra on the issue of laser use in clean rooms, which once again is an environment that typically doesn't fit in the typical laser standard. Where do you need a warning sign? Do you have visible light? Where do you put it? The whole ergonomic issue of working in clean room clothing, which is much different than the grad student running around in jeans and a t-shirt, type of thing. So we're constantly trying to catch up, but laser safety people need to be aware of what's going on and how they want to adapt to it.
Hmm. Hmm. Awesome, Ken. Hey, so looks like we are bumping up on time. If you could take just a couple seconds and let people know how that they can find you out there, Ken.
So I uh, I'm behind the top. Well, I had a website and got rid of it because no one ever went to it.
Hmm.
So basically, if you want to get in touch with me, uh, my email address is lasersafetysolutions@gmail.com. And that's my email address because when I retired from the Department of Energy, I got a contract to do some training for Los Alamos Laboratory. And the contract people said, no, you can't say contract is with Ken. We want a company name and more formal and all of this. So, you know, you know, sitting down with a bottle of single malt, came
Hmm.
up with the title, and that's so my company name is like Laser Safety Solutions, but the company is me. So laser safety solutions at gmail.com is how the best way people can get. I'm also on LinkedIn, you can find me there.
Hmm.
But always happy to answer laser safety questions. And if it's a question by email, it, happy to do it. It's not like calling your lawyer and the clock starts. Happy to share my experience with everybody out there.
Great, Ken.
All right.
Great, kid. Thank you. Thank you so much. I didn't have a chance to even ask half of the questions that I had. So we'll look at getting you back on here if this was a positive experience for you. So,
Oh,
and with that, we are over with 167 with Ken Barat.
Barat.
Barrett. I'm sorry, Ken. Thank you so much, Ken. Have a
All
great
right.
day, bud.
You too now. Bye bye, folks.